All right, we're going to do the last and final chapter of the year. Can you believe it? Yes, I can, and I am fired up. All right, so we're going to explore solids. These are your three-dimensional figures, okay? The first kind are ones that are made up entirely of straight lines, okay? They're called edges on these. These are called polyhedra or polyhedron. If there are two bases that are exactly the same, that's going to be called a prism. If there's one base, that's going to be a pyramid. And if you ever want to know how you have to draw a prism or a pyramid, they're actually pretty easy, okay? For instance, this prism here, this is called a rectangular prism. The reason are it has two bases that are rectangles, so it's a rectangular prism. Down here, this is called a pentagonal pyramid because the base is a pentagon. So here's what you do if you ever need to draw these. For a rectangular prism, just draw two rectangles and then connect upper left with upper left, upper right with upper right, and then the bottom right, bottom left. You get your box or rectangular prism. For a pyramid, draw your, in this case, pentagon, put a dot above, and then from that dot, all you do is connect the dots to each vertex and you get your pyramid, okay? Next we have our non-polyhedra solids. These are ones that are not made up entirely of sides, okay? You have your cylinder or a can. You have your cone, which we all know those, goes best with ice cream on top, and a sphere, which would be a basketball, a baseball, a golf ball, something like that. Again, things that we've already seen many, many times. Now, in this chapter, in this section, we have this thing called Euler's theorem. Euler's theorem deals with only polyhedra. So we're not talking about cylinders, cones, and spheres here. We're only talking about prisms and pyramids. The theorem says that the number of faces plus the number of vertices equals the number of edges plus 2. Okay? Now, here's the thing with this, and you might want to write this down. You could probably pause the video and write this down. Instead of counting every single time on a prism or on a pyramid, we actually have a way of figuring out how many faces, vertices, and edges there are. So in a pyramid, the number of faces would be the number of sides on one of the bases, or, well, there is only one base for a pyramid, but the number of sides on one base plus 1. The number of vertices is the number of sides on the base plus 1. And the number of edges are the number of sides on the base times 2. And what I did was I put that in the Euler's theorem to show you how it works. For instance, if we made the number of bases n, for faces, that would be n plus 1. So there's my n plus 1. Remember, f plus v n plus 1. That should equal edges times 2, which is 2n. And then remember, it's e plus 2 on the right. So that's 2n plus 2. So notice how they work out. For the prism, same thing going on. Faces, number of sides plus 2. Vertices, number of sides times 2. Edges, number of sides times 3. So if I put that in Euler's theorem, F would be n plus 2. V, n times 2. E, n times 3. And then remember, it's F plus V, which is 3n plus 2, equals E plus 2, which is 3n plus 2. So again, back this up. You might want to pause the video, write this down. That way you don't have to copy or count every single time on a pyramid or a prism. So for instance, if we did one of those rectangular prisms, F, V, E, I can show you. Look, you want to count? Okay, number of faces. Front and back, that's 2. Left and right, that's 4. Top and bottom, that's 6. Vertices, let's count. 1, 2, 3, 4, 5, 6, 7, 8. And then edges. 4 on the front, 4 in the back, that's 8, 9, 10, 11, 12. And if I put that in Euler's theorem, 6 plus 8 should equal 12 plus 2. And it does. But what happens if we go over here and instead of counting, we just use these instead. So I have a prism. The number of sides on my base, it was a rectangular prism, so there's 4 sides. So that's 4 plus 2. How much 4 plus 2? 6. Vertices, number of sides on the base was 4 times 2. That gives me 8 vertices. Number of sides on the base was 4 times 3 gives me 12 edges. So instead of having to count, you can just put the number of bases, the number of sides on the base into these for either the pyramid or the prism, and it's going to work out just fine for you. Okay, let's take a look at some examples. All right, so let's take a look at some examples from the packet. We're going to do 4, 7, and 10. Okay, and again, if you didn't pause and copy down those little formulas there for the pyramid and prism and how many faces, vertices, and edges there are, it's probably a good idea to do that because you're not going to find it in the book. That's just something that I gave you that's extra. All right, so let's use Euler's theorem here for number 4 to figure out what n is. Okay, so I know my formula is F plus V equals E plus 2. So now we're just putting them in. Number of faces is n. Number of vertices is 4. Edges is 6 plus 2. So n plus 4 should equal 8. That means there's going to be 4 faces. All right. Number 7, they want us to draw a triangular pyramid. So that means your base is a triangle. If you remember from at the beginning of the video, when it's a pyramid, put a point above it anywhere. Doesn't matter. From that point, just draw a straight line to each vertex and you're going to get your pyramid. Okay? If it was a rectangular pyramid or something like that, like if it's a rectangular pyramid, draw a rectangle, put a point above, draw one to each, draw a line to each vertex. Okay? Number 10, they want to know how many faces, vertices, edges there are. All right? So, faces, again, you can count or you can put it into the formula. Well, I know that this is a rectangular pyramid. So if I go to pyramid, faces is the number of sides on the base, which is 4, plus 1. Vertices, number of sides on the base, 4, plus 1. And then the edges, number of sides on the base, 4, right, times 2. Okay? So, let's take a look. Let's count and see if we were right. That we should get 5, 5, and 8. Well, let's see. Count the faces. Base is a face, and then there's 4 triangles going around. So there's my 5 faces. Vertices, 1, 2, 3, 4, 5. Edges, the 4 for the base, and then 1 edge coming from each point down to each vertex. That's 8. So if we put that into Euler's theorem to check, 5 plus 5 should equal 8 plus 2, and that checks. Okay? So your job, page 226, 227, do 1 to 15. Wash your hands, save a life.